Hey guys, all right, so this is the working prototype for the Smart Visor online version at the University of Advancing Technology. So what we have here is we have our display hooked up. It's running to an Adreno right now. We're going to switch it to an ESP32. And we have the real-time clock right there. So as you can see, it is showing a space for the compass. It is showing the time in 24-hour intervals, the date, and the temperature. Really, all we need is the time, so I can adjust it just to show that, and we can use some more of the screen space for something else. But I wanted to show you something really fast here. If we reset it, so it just says it's a smart visor. It loads. It says UAT 2022 on it, and then it'll go right into the compass and the clock. I am going to walk you guys through the code right now for that. But so far, guys, success. Congratulations, everybody. We're well on our way. All right, now on to the code. Bye bye. Okay, guys, here's the code. Oh, wait, I've got to save this off here. Hold on one second. All right. There you go. Smart Visor, version 1. Okay, here's what we do, guys. All right. Just to let you know, the display is a 240 by 240 TFT display. We are going to be using a library for that, and I'll get to that in a minute. But before we do that, I have to tell you the pinouts. So on the display screen, you're going to see these variables right on the display screen. Ground is GND, that's ground, it goes to ground. VCC is the voltage source. It says 3.3 volts, but that's false. It is running at a 5 volts. So it goes directly to the 5-volt rail. Um, this is the clock, the send clock data. It's going to be on pin 13. Now, that's not the clock as in the real-time clock. That is to synchronize the display to the clock, the internal clock to the microchip. Then we have the SDA. It's going to be on D11, on pin 11. Reset is going to be on pin 8. DC is going to be on pin 7. The screen black is not even hooked up. So here's what we do. For the real-time clock, we include the DS3231.h header. That's the name of the real-time clock. It's the DS3231. It can display the clock. It can display the time and date, and also the temperature. We include wire because we're going to be transferring the data over over I2C, and we're going to be using the SPI bus to do that. We include the. Oh, wait a minute. Sorry, guys. This has to go bye bye. That was for another project. All right, so we include timer one header file, and that helps us with the time as well. Um, I have a variable here, but this is going to be used for something else. So we don't need this right now either. That was for switching screens from another project. Sorry, guys. Okay. Anyway, moving on. So to set the clock or to call the clock, we use this code right here. This DS3231. We call it clock one. Okay. So we're not using the century. We put that to false. H12 flag and the PM flag we are using. So this is the 12-hour flag and the PM flag, which basically we can simulate it AM, PM, or go through the 24-hour stuff. Um, it does have a thing for an alarm. We're using the hour, minute, second, and the alarm bits, but we're not using the alarm actually, but it's in there. Um, and then we have a bool that will ask us if these flags are active, the 12-hour flag, the PM flag, or the alarm flag. Okay, I know it's a lot, but once you see the code for yourselves, you'll understand it. And if not, get a hold of me and we'll go through it. So we are also including the SPI header file because we are using the SPI, which is a way for the Adreno to, communicate with the other stuff that we're using with it. We're using the Adafruit GFXH library, in the Arduino ST7789.fast library, which I might have to send to you guys. So what these libraries do, well, the ST7789 is what I'm going to have to send you. So what you need to know is the ST7789, that is the name of the display. So that is the driver that the display is using. Now that driver also uses the Adafruit GFX library, which is in the Arduino library. You just have to include it, if that makes sense. So in other words, I'm going to send you the ST7789 library so you can input or interface with the LCD or the display. Sorry, guys, I am tongue twisted today. I apologize for that. So anyway, that will let you use the display. Do you need it? Probably not, especially if we're going to be doing all of this stuff here where I'm at, putting it all together here. But it's nice for you guys to have so you guys can play around with it. Um, so yeah, so we define these for the display. I use defines because it doesn't take up any memory. If we were to put these into variables like integers and stuff like that, it would take up space. But when we use define in Arduino, it basically just does this on the fly. So we have to call the LCD screen, and this is how we do it right here. This is the code for that, just to let you know. You just copy and paste that whenever you want to call the screen, or whenever you want to use the screen. You only have to do it once before the setup. So setup, we are using the serial monitor. Wire.begin, because that is going to start your I2C, your data transfer. And then when you are writing to the LCD screen, this is how you do it. So first thing we do is we call LCD.init, that initializes it, the screen width and the screen height, which is right here, 240 by 240. So we just say, we're going to make this screen 240 by 240. And then we fill the screen to black. That fill screen is going to set the background color to black. So in order to write to the screen, you have to set the cursor, which means you have to tell the LCD screen where to write, okay? Where to begin it. So this is going to be the width and the height right here. So 60 pixels over, 10 pixels down. Then you set text color, and then you can call different colors. So the red is going to be the color of the text, and black is the background color, okay? Now, if you've taken the I2C class and you're used to working with the M5 Stick C, this should be a no-brainer to you. But I know some of you guys haven't done that yet. So get with me and I will walk you guys through this part 100% because I know it might be a lot to take in on this video. And I'm better at showing things hands-on than I am explaining stuff in the video. So this LCD set text size, that's the size of the text that you're going to be using. 1 is very small, 2 is kind of in the middle, 3 is bigger. I set it to 2 right now, and we print out Smart Visor at these coordinates using red, and you'll see that. That's why it says Smart Visor in the beginning. Okay, we set the text to 2, put the text to white, the black background. We set the cursor to this thing, and we put version of it. Anyway, all of this is your splash screen at the very beginning, okay? So then I have the loading part blink, and I use a for loop for that. And we do all of this text stuff to the LCD screen. What you need to know with the LCD screen, if you want to use it, you have to put LCD, then dot, and then whatever you want to do. So if you want to set text size, you do that. If you want to set the text color, you do that. If you want to set the text cursor, you do that. If you want to print to it, you have to do this, okay? So that's how that works. And then we delay, and then we basically print nothing in the part where it says loading. So you have to actually erase it by doing this, if that makes sense. So for as many characters there are, you need blank characters. Otherwise, you're going to get artifacts, or you're going to get like an L there or G or something like that. So that's how that works. So after that goes away, We print, this isn't setup, we only do this once because here's the thing. So we print compass, we print the time, the date, the temperature, we print all those words one time. Because when the loop is happening and you're updating all of that stuff. If you were to update that stuff in the loop, each time the loop would run through, you'd get a flicker. So you don't really want to see the words flickering. So we know where those are going to be at, where we're going to put those on the screen, right? So we just do that once because that's never going to change, right? What does change is the time in numbers, the date, and the temperature itself. You know, the actual numbers are going to change. So we put that in the loop, and I wrote a function for that called time temp, and I put that here in the loop. Now, after the loop is where I wrote the function for that. And all we do is we print out the clock and the hours, the minutes, and the seconds. And this is how we do that with the clock. So we call the clock, we say get hour, and then we use the H12 flag because we're and the PM flag, and then we set the month. And we get the minute, and then we get the second. Now it says December right here. We can change that, but actually, we can actually get it to run off of the computer clock or the car clock once it's ready to go into the car. But for now, I just have it there. I was kind of pressed for time, so I didn't update it pretty much. So we do an if statement. If it's a 24-hour flag or if it's a 12-hour flag, we either print AM or PM. All right. Or if it's not AM or PM, then we're going to print 24 hours. I have it on 24-hour time. I figured that would probably be the best at using it right now. And then we set the cursor, and then we print the month, date, and year, and then we print the temperature, and that's easy. You'll be able to see this in the code. If you have any questions, let me know. But anyway, that's that. So that's the basis of that. And I know it seems tricky, but here's the deal with this. All of these things are in the libraries that we're using. So you can look that up and it'll tell you that. If you have any questions, you let me know and I will walk you through it personally. So when you're translating your pseudocode into normal code, this is how we would print it. But what we can do is we can have you guys work on the code that actually is supposed to work, and then I can take that and then I can implement the printing to the screen if you guys want. As long as it works, right? So there's more ways, there's more than one way to skin a cat, and I am totally open to that. But as of right now, we have it working. Here it is. Congratulations, guys. We are on our way. All right, guys, have a good one. Bye bye.